So hello everybody, my name is James Thomas and I'm a software engineer and I work in IBM's cloud division. And the title of my talk today is Taming Dragons, and hopefully in a couple of slides time we'll kind of see why I've used this metaphor. But what my talk is really about is how as you, as developers who are building serverless apps, can maybe build serverless apps that target different service providers, right? How can you build apps and maybe move them between providers without having to do loads of re-architecture to make this work, or learn the intricacies of how you set up an API gateway on every single platform. And what I'm going to show you today is how to use a new feature of a really popular open source framework, the Serverless Framework, which added multi-provider support recently to make this task of building multi-provider service apps much easier. Now I think 2016 was just a huge year for serverless, and it was the year that the kind of movement really took off. And I think one of the ways this is kind of manifests itself is that all of the other cloud providers, right, kind of launched their own service solutions. So you go back to 2014, and Amazon launched serverless when they launched Lambda at their conference at the end of 2014. And then last year, I think all of the other cloud providers kind of realized the benefits of building applications using serverless platforms and kind of rushed out their own solutions. So IBM has one called OpenWhisk, which we donated to Apache earlier this year and is open source. Microsoft have one called Azure Functions. Google Cloud have one which came into beta recently called Google Cloud Functions. You can see there's like a theme in the names. There's some small providers like WebTask and IronIO. And also, if you're using Kubernetes, there's a number of open source projects now that are trying to build serverless systems on top of Kubernetes. So suddenly, you know, serverless is not just an AWS thing anymore. It's across all the cloud providers. Whoever you use, they pretty much have some kind of service solution. I think as developers, right, as service developers, this is what you want. You want the vendors competing against each other because that drives competition, it drives evolution, they add new features, and it just means you get much better stuff to be able to play with. So if you, maybe you've been an early aggressive adopter of Lambda, and you may be looking at some of these new providers that are coming out and thinking, well, you know, why would I switch providers, or why would I maybe build my service app to use multiple providers or move them from one provider to the other? It's all just serverless, right? It's no ops, it's fast, you know, what's the difference? But I think if you look at some of the new providers and kind of compare them, there's a number of reasons why you might like to target certain apps at certain providers. The first might be performance, right? So maybe you were just a very early adopter of serverless and realized the benefits when it was just an AWS technology, but it just so happens that the rest of your company is a big Azure user, or a big SoftLayer, or a big Google Cloud, and so your service apps end up spending a lot of time talking to those resources. And now you might think you can get better performance by co-locating your service app in the same data center as the rest of your organization. Right, it might also be kind of geographic. Maybe you want to expand into a new region where your particular provider doesn't have a service instance, and so you think, well, I'll just go and use another provider to be able to use my service platform. Runtime support is something else I think kind of interesting. If you look across all of the big service providers, there's a couple of key runtimes that are supported across all of them, right? Some version of Node, some version of Python, some version of Java. That seems to be pretty common these days. But one of the ways that the providers are trying to differentiate themselves is providing kind of slightly more interesting runtimes. So in OpenWhisk, we have Swift supported out of the box as a first-class language. On Azure, for example, Azure Functions, you have things like F#. So if you want to use a newer version of Node that Lambda supports, or you want to use something slightly more esoteric, again, you might choose a particular provider to take advantage of that runtime. Another thing people are kind of talking about is becoming more popular is trying to use open source service platforms. So again, I think anyone who uses cloud has this nagging feeling that they're going to be tied into their vendor for life, whether they turn the service off or they change the pricing model, and you're just kind of stuck, married together forever. And I think one of the ways that developers like to mitigate some of that concern is building on some kind of more open source components. And now there's a number of open source service platforms out there that you can use, hosted or run yourself. OpenWhisk is one of them. It's now been donated to Apache. There's things like Fission, which run on Kubernetes, if that's what you're particularly interested in. And I think I'm seeing more and more interest in people using service platforms that are under the covers, like kind of open source. And then a final reason people are kind of evaluating some different providers is some people think the way to build resiliency in your service apps is to go multi-provider, right? So when your provider's object store goes down for a couple of hours, you know, you can fall back to using another one. And actually, you know, could you deploy your service app in multiple providers and provide some resiliency that way? So I think there's a number of reasons why people are now, with all these different choices of providers that have come out, are looking to think a bit harder about which provider they use for their particular type of serverless app. And you might have read about some of these new providers and you might think, okay, this sounds cool, right? I can get a new version of Node, or I can use F#. So I'm going to register an account, I'm going to take one of my applications, I'm going to throw it over to this new provider, it's all going to work magically because it's no ops, it's serverless, it's all just going to magically happen. But unfortunately, that is not true. And this is where the title of my talk comes from, because here be dragons, right? The idea that you can just take one service app from one provider, kind of lift and shift it over to another, and it all works magically, is where dragons come from. And if you try and do this, you'll find yourself in the pit, hiding from Drogon as he tries to turn you into a kebab. And I think the reason for this is that serverless it's a very emerging space, right? It didn't even exist about 2 years ago. And all the different provider implementations are kind of, there's no standardization, there's no specification, you can't just move apps between different service providers. And I think this has been a barrier to adoption of thinking of using different providers. You might think, well, maybe I want to go and use a new runtime and a new provider, but do I have to learn all the intricacies of how do you set up an API gateway, how do I deploy my application? It just doesn't seem worth it, right, if you want to use a slightly newer version of Node that one particular provider supports. Which is why I was really happy or interested to see one of the big open source frameworks for building serverless apps kind of take on this challenge of giving you a bit more of an abstraction layer, which makes it easier to move your applications between different providers and get started much quicker. And that framework was the Serverless Framework. So hands up, who's heard of the Serverless Framework before? Right, cool, okay. And who uses it day to day? All right, pretty awesome. So I think it's wonderful. I think it's a really good framework, and it lets you do the whole life cycle of building serverless applications, of creating boilerplates that are ready to go, deploying them, monitoring them, and all that kind of stuff when they're running in production. There is a number of serverless, open source frameworks for building serverless apps, things like Apex or Zapper or Chalice. I think it's fair to say that the serverless framework is by far the most popular out there today. It's got like 14 bazillion stars on GitHub. It's got a huge ecosystem of users and people building plugins to extend functionality. And I think it's just a really wonderful tool. The people behind it are also pretty awesome. And last summer I was kind of digging around in the source code to understand how it worked under the covers and kind of trying it out. And I started to notice that they started to make some changes to the project to allow support for multiple providers, right? Obviously it began when there was only AWS Lambda was the only service provider, but now you have other options, and they started to make some architectural changes to add support for other providers. And about 8 weeks ago, version 1.6 came out, and the big feature in 1.6 was that they had multi-provider support, right? So now you could use it with different service providers. And I was the developer at IBM that took on the task of integrating OpenWhisk, which is our open source service platform, into the framework. And OpenWhisk was the first non-Lambda serverless framework or provider that was integrated after Lambda. 3 or 4 weeks ago, Azure Functions came out with their integration. Google Functions have now come out with their integration. So I consider them the big four. You can now use the same framework to build and deploy applications to any of those providers, right? The same workflow, the same tools, all the same plugins, all the kind of service awesomeness, but now you can use multiple providers. So what does this actually look like if you're using the serverless framework to kind of build service applications? Well, for those of you who aren't kind of familiar with it, and this is what it kind of looks like, right? Serverless Framework is an npm command you install as a global module. It gives you this service command in your CLI, and you can do things like, say, create with a template, and it will give you a fully, kind of instantiated boilerplate for a sample serverless app for your particular provider and runtime. You can then, once you've set up your credentials, just type deploy, and it will handle the whole deployment lifecycle without you having to do anything else, and it will set it up on your particular provider, and then you can kind of monitor it when it's running in production. It gives you some tools to make this a little bit easier. And when you create your new service application using the framework, at the heart of your application is a manifest file, which looks a little bit like this. It's called serverless.yaml, and it allows you to specify all the configuration for your application, right? What's your service called, who's your provider, and then you have this section where you actually define the functions that you want to deploy, right? What's the source code, where's the JavaScript file in this instance that you're going to run, any options, any runtime parameters like, how much memory does it use, what's the runtime, the timeouts. And then it has a really, really simple configuration for binding events to it. For serverless, it's not just functions as a service, it's also the event model, right? You want to listen to database updates to message queues to all kinds of stuff going on, and it provides you with a really nice simple configuration where you can just say, as me an API gateway, that's what the path looks like, and you work out. And it just really reduces the barrier to entry of getting started with serverless development. So at a high level, and I'll go into some of the implementation details in a little minute, if you wanted to move this very, very noddy, simple serverless app from AWS to another provider, all you have to do at a high level is change the provider name, and the framework will take care of everything else. So when you type serverless deploy, it's going to target a new provider, it's going to do all the API requests under the covers to deploy your app, and you don't have to worry about exactly how that works under the covers. And it provides you a bit of an abstraction layer, which takes away some of the details about how to get started. So you might think, awesome, right? Now, kind of release the dragons. Now I don't have to be scared of these different providers and how they'll work under the covers. I can use the serverless framework to help you get started. So let's have a look. Let me do a live sample demo showing you how this works in practice, and then look at moving an app between these two different providers. In about 5 minutes, we'll kind of show you how this works in practice. So let me sit down. I can have a gulp of water before I do this. So, see that? Go to my terminal. Cool. Can everyone see that? Does that fit at the back? Okay. So I have already obviously signed up for my account credentials and set them up environment and all that kind of stuff. And I've already installed the serverless tool. So you have this command called serverless, which gives you all of these commands you can run to kind of interact with the workflow of building serverless applications. And they have this command called create. And what create allows you to do is create a new serverless app. And you have to specify a template, and you can see the templates for the provider and the particular runtime. So we have things like Node.js, Python, and Java on AWS. But what you'll notice is that we have providers for Azure and OpenWhisk in there as well. So if you decided, right, I want to try out a new provider, I want to try out OpenWhisk, all you have to do is say create. You give it a template, which is OpenWhisk, Node.js. You give it a path. Let's just say hello world. And it's going to scaffold you a sample boilerplate application that's ready to deploy out of the box for that particular provider. So I can say, okay, let's have a look at it. So this is the directory structure, and again, this will be the same kind of structure of the files and configuration for any of the different providers. You don't have to change any of that. And at the heart of it, we have you have a little JavaScript file. This is for the Node.js runtime, just a kind of greeting service that's going to run on demand when we deploy it. And then we also have package.json, which you can put any of your kind of dependencies in. And then we have what is the kind of heart of a serverless app, which is this YAML file, which is all filled out for your particular provider, right? So it's got the provider name, gives some details about how to use it. You can see I've got this function called hello that I want to deploy. And then down the bottom, it has the plugin for the particular provider. So if I wanted to deploy this to this new serverless provider that I don't know anything about or how to really set up, once I've installed the plugin, all I have to do is type serverless deploy. And it's going to bundle up my app, it's going to talk to the provider, it's going to deploy it, and it's going to give me the details when it's actually deployed. So you can see, right, there's my endpoint targeting openwhisk.ng.plugins.net, service is called hello world. There's some of the functions that I already had deployed in there, but you can see there's this hello world dev hello that seems to be up and working. And using the framework, I can then kind of invoke it. So I can say invoke my function hello, and it will go and make the platform request and give me the result out down the bottom. So that's the serverless function running on this OpenWhisk platform that I don't know anything about. I don't know how the underlying mechanics works, but I've used to use the same serverless framework I do with Lambda to be able to deploy it, and it kind of gives me that abstraction. So let's look at a little bit more of a complex example. I have this application called ASCII cows, which I have running in Lambda already. So if I type serverless info, it shows me all my kind of service information. So I've got a function, it's got an API gateway endpoint which I can call. And this is a really important service. It gives me ASCII cows on demand. So you can see as I call the API, I get some ASCII cows back. So this is a really important API. If you want to use it, you can ask me for an API key afterwards. And for performance reasons or something like that, I decide I want to run it on another provider because importance is super important with ASCII cows. So, again, at a high level, if I wanted to move this to OpenWhisk, I can change the provider name. So I want to deploy it to OpenWhisk. I'm going to change the handler because, for reasons we'll look at later. And then I need to just add a plugin because it's a third-party provider. And now I type serverless deploy. and hopefully it should work. So it's going to package it up, it's going to talk to OpenWhisk now, not Lambda, and then hopefully I'll get an API endpoint when I call it. It should be the exact same serverless function running on a totally different platform. Cool, right? So there's my API gateway. So another API gateway on another cloud provider, but it's been set up for me. I don't have to worry about the implementation details. And once again, there we go, ASCII cows on demand on a new serverless provider, right? So pretty cool, right? You know, it allows me to use the same framework and workflow, and I just get to change a little bit of configuration. So cool. So let me jump back to my slides now. So you can see why I think this is such an awesome feature of the framework and why it gives you so much power. It really reduces that barrier to entry of getting started with new providers by kind of abstracting away against some of the details. And you might now think about, well, this is awesome, right? Now I can use different providers, and you might get comfortable with deploying apps to different providers. And you might move simple apps between the different providers, but then what you'll do is you'll think, I know, I'm going to take my really big complex Lambda app, I'm going to move it to another provider, and then when that happens, there's more dragons, right? Because although the Pup framework can abstract some bits of using the different providers, it can't abstract everything, right? All the providers are very, very different, and you just can't really get away from that, and so it's much more difficult to take a bigger app. You have to be aware of a few things. There's a few dragons that come out when you start to do more big development, move it between different service providers. And I think there's four dragons to be aware of if you're thinking about using some of these different providers. And the first is interfaces, right? When you're using the serverless platform, what you have to do to your code is you have to add a little interface, which is the kind of hook into your code from the platform. When a request comes in, it kind of invokes it on demand, and this is a little bit different for every runtime and every provider, and it's important to think about that. So for example, if we look at the Node.js runtime, this is what the functional interfaces look like for each of those providers, right? And you can see that at a high level it's all the same, right? You're returning a function that's going to get called with some parameters and return some data. Unfortunately, they're all slightly different, which is pretty annoying. They're not all the same, but you can see it's things like, on Lambda and OpenWhisk and Google Cloud, you return a function attached to a property on the exports object. In Azure, you return the function as the exports property itself, right? And again, how do you get data in? They all pass data in as parameters. In OpenWhisk, you get one object with all your parameters in. In Lambda, you get an event, a context, and the callback. With Azure, you get context, and then every parameter is a separate argument. So again, unfortunately, just slightly different. And then how do you get data back? So some of them use a callback approach. OpenWhisk allows you to use a promise, kind of more modern JavaScript. But even though they are conceptually the same, right, there's all some small differences, which mean you can't just take one function designed for Lambda and move it to OpenWhisk and expect it to kind of work out the box. Now, I think this issue is fairly easy to resolve, and there's two things you can do. One is you can obviously abstract away your core business logic to your service function away from the actual kind of interface that interacts with the platform, and then just write a little wrapper when you want to deploy it to a new platform. That's pretty easy to do. But actually, I think this is something the framework could pretty much do for you, right? You could write your serverless adapter interface in a kind of vendor-neutral fashion, and actually the framework could just write the wrapper for you at compile time, kind of, transpiling your code and wrapping it. And actually, I think the framework could probably handle this for you. So interface, the first dragon, that was pretty easy to slay. It's not very difficult to kind of get around that. As long as you know what the interface looks like, it's pretty easy. It doesn't take a lot of time. So the next dragon to think about is the runtime dragon, right? With serverless platforms, you're obviously reliant on the platform to do everything for you. You don't have to set up that environment and manage it yourself, but it means you're kind of beholden to the runtime that they use. So if we look across the big service providers, so I think that's OpenWhisk and Lambda and Azure functions and Google Cloud functions. Again, I think there's the big three. They all support usually some version of Node, some version of Java, some version of Python. And Node is the first class, I think, serverless language, right? It's supported across pretty much every platform out there. You can see that 3 of them, which is the non-Lambda ones, support version 6 of Node, Lambda supports version 4, but they're all kind of modern JavaScript environments, right? It's ES6 and that kind of stuff. So moving your Node code between those environments is probably pretty easy. Python, again, Python 2.7 is supported on all of them apart from Google. So again, that's kind of consistent, which is pretty awesome. Java is a bit more spotty, so it's only supported on OpenWhisk and AWS Lambda, but it's both version 8, so that's pretty good. So if you're sticking to the core runtimes, you actually get pretty far. But what is the bit of a challenge is where they're trying to differentiate themselves from each other is by providing more interesting runtimes like Swift or like F# and things like that. And obviously those particular runtimes are not going to be portable to someone else. And some of the environments like OpenWhisk and Fission allow you to push raw Docker images in with completely custom runtimes if you want to use Rust or Go or something like that. And again, that's not really going to be that portable. So runtime's a little bit more difficult. It's, if you're sticking to the core nodes, no codes, then it's pretty easy. If you want to use F#, your mileage may vary a little bit. Third dragon to think about is events, right? Functions as a service is all about the events you can attach it to have it invoked on demand, whether that's a message queue or a database or something like this. And this is a bit like the runtimes, right? So if we look at those 4 prior providers again, they all have similar categories of events. So they all of them have some kind of API gateway you can put on the front of your function to invoke it for an API request, kind of request response, which is pretty awesome. Most of them have some kind of cron service. So I want to be able to call my function every hour, every minute or something according to some pre-specified schedule. All of them apart from Google. They all have some kind of message queue that you can attach your functions to so they get invoked on demand. On AWS, it's going to be something like SNS. On OpenWhisk, it's going to be Kafka. I'm not sure what it is on the other providers. And most of them, apart from Google, have some kind of database thing that you can listen to updates from, right? I'm not sure what it is on AWS. They have a few. On OpenWhisk, we have CouchDB in there. So at a high level, right, they all have the same categories of events. Obviously, the challenge here is that the actual implementations and the details of those events are going to be very specific to that particular environment, database or queue or something like that. So again, if you're writing some kind of, some message listener, it's going to be very, very specific to your provider's implementation, and you're not just going to be able to kind of lift and shift so easily. So you're going to need to do a little bit more work, even if there is a kind of equivalent service on another platform. The fourth and kind of final dragon to think about is, I think, the use of SDKs. When you're writing serverless functions, often you're using other resources from the platform, and the way you'll do this is you'll use the client SDK. And that is obviously very, very provider specific. So here's an example of invoking a Lambda function in Lambda and invoking an OpenWhisk action, as we call it, in OpenWhisk. And again, if you look at conceptually, it's the same kind of code, right? You get the client library, you kind of pass your credentials in, and then you invoke it and get the data back. But obviously that code is completely provider specific, right? The Lambda code is not going to work on OpenWhisk and vice versa. So if you've got lots of this code littered throughout your serverless functions, right, it's going to be a lot of work grappling through to kind of swap stuff out, and that is a bit of a pain, really. Now, interestingly enough, when I was digging around in the Serverless Frameworks organization on GitHub, I discovered this project, which is Stadlib Node.js. Now, I don't know if they talk about this. I'm not sure it's secret because it's on GitHub, but they've not really talked about it, but they are developing it, and it's a standard library for Node.js on serverless runtime. So if you want to call a serverless function, you can use this library, and under the covers it will work out what platform you're on and do the kind of client SDK to make the invocation, and you don't necessarily have to use the client SDK yourself. So for simple invocations, you could be using this library and actually not having to use the client SDK directly, which I think is a kind of really interesting thing, and I hope they keep kind of developing it, and maybe I'm talking about it, it's going to encourage them to do something with it. So SDKs is a little bit more difficult, right? If you're doing some sample invocations of just chaining serverless functions together, it's not so bad. If you're using the client SDK to provision those resources, that's going to be a little more difficult. So not so easy to do, and hopefully maybe the framework will kind of step in and help out a little bit with that. So I said at the start of this talk, right, that I thought 2016 was the year serverless kind of, was on fire, kind of blew up. And one of the reasons you think you can see that is because all of the other cloud providers have kind of rushed out with their own server solutions, right? Whoever your cloud provider is, you can pretty much guarantee they have a server solution. You can't really swing a cat these days without bumping into a new serverless platform on Hacker News. And they are all trying to differentiate themselves, all these different features and the runtimes and the services and the events, which is good for us as developers. And you might want to go and try them out and kind of go, okay, I want to use a newer version of Node, I'm going to jump into one of the providers. But what you'll soon discover is, as I said, here be dragons, because there's a lack of standardization and specification. All providers are completely different from each other. Even if that provider is open source, you can't just lift and shift applications between them. And this was a big barrier to adoption for many people, right? If I just want to use a new version of Node, is it really worth me browsing those documentation about how API Gateway works on OpenWhisk? Probably not. Which is why I was kind of really excited to see the Serverless Framework step up and try and help with this problem of providing you with an abstraction layer that helps with the whole deployment workflow and setting up some of the resources and really reduces the barrier to entry of getting started with serverless apps. So if you are building serverless apps and you're thinking about trying different providers and you're a little bit put off, I want to encourage you all, right? Go summon your inner Khaleesi. Don't be afraid of these dragons anymore. Tame them by downloading and installing the same serverless framework and using that as your abstraction layer to help you get started. So thank you very much. Thank you all for listening. I've got time for questions or we're going to chat afterwards. If anyone wants any help with OpenWhisk stuff and getting started with that, then you can find me or we have a Slack channel as well. So thank you very much.